This video is a step-by-step guide on how to integrate a physical collision sound system on an object. This video will explain how to set up the system on a box. The system works with the general impact system and a specific impact system. The general impact system works with trigger boxes that detect multi-contact collision. So, it is used to detect and distinguish if an object collides on a corner, edge, or surface. The specific impact sound works with UV light maps. In contrast with the general impact system, the specific impact system utilizes UV light maps as a way to create audio regions within the object. Both of these systems affect the parameters and branches inside the impact and slide roll sound cues. Both systems control a switch integer parameter in these sound cues that allows to change the sound accordingly to that parameter. If the trigger box's checkmark is activated, the general impact takes priority over the specific impacts. This means that the lowest integer for the switch integer parameter in the sound cues is reserved for the impact sound cues. The general impact system is designed to change the variable to 1 if the object collides with only one trigger box, 2 if the object collides with two trigger boxes, and 3 and 4 are reserved for different types of surfaces sounds. If the user wants to add another unique group of trigger boxes, it has to add another output to the switch group inside the general impact's collapse node. If the general impact system does not detect overlaps in any of the trigger boxes, it changes to the specific impact system. Using buttons inside the widget, the user can create areas of sound within the object and attribute each area to a specific integer. The user must have into consideration the last number used in the general impacts and make sure that the numbers on the buttons align with the counting from the general impact system. The tutorial starts now. Step 1. Replace the static mesh component, the impact and slide roll audio component with the respective components. Trigger boxes. Step 2. Analyze the object and check if it has corners. If there are corners in the object, it is necessary to use trigger boxes. This way, it is possible to distinguish if a hit happens on a corner, edge, or surface of the object. Start by adjusting the existing trigger boxes to each corner of the object. Step 3. Replace the on-component hit node with the one of the imported static mesh inside the trigger box's collapse node. Also, change the component hashtag node for the tag of the trigger box. Give the tags a unique name. Step 4. Still inside the trigger box's collapse node, create groups of trigger boxes if necessary. This causes the collision to recognize different surfaces. In this case, the cube has two different types of surfaces, big and small. The groups of the small surfaces types are boxes 4, 7, 5, 6, and boxes 3, 2, 1, 0. The rest of the groups correspond to the big surfaces type, so it is not necessary to manually create these. Connect each of the groups to a branch and set the trigger amount variable to the group's value. In this case, the small surfaces correspond to 3 and the big surfaces correspond to 4. UV sound map. Step 5. Go to the static mesh and take a screenshot of the best UV map. Lightshot is being used to take the print. Import a screenshot into a real engine. Open or create a widget blueprint. Set the screenshot as the image. Go back to the collision system blueprint and assign the number of the selected UV map and change the create widget class to the created widget. It is necessary to set the widget ref variable type to the selected widget and connect it again. Step 6. Go to the specific impacts collapsed node, refresh the widget reference variable, get the reference button from that variable and connect to the slot as canvas slots. Compile. There's going to be an error with the widget reference variables. Simply refresh these and connect them again to the respective nodes. Step 7. Play the game and press scroll lock to disable the instruction sprints. F12 to show the widget and end to enable middle mouse UV. If the user presses with the middle button on an object, you will see the location of the hit in the UV light map. This allows the user to know exactly where to create the area regions. Step 8. Now that the area regions are planned, it is necessary to go to the widget and create these regions with buttons. It is important to note that if two buttons with different z-orders overlap on top of each other, the one with the highest z-order number takes priority and overtakes the other one. Drag and drop the buttons to the respective regions, and for each group of sound regions, assign a unique z-order. After setting up all the buttons, compile the widget. Step 9. In the specific impacts collide node inside the collision system, get all of the buttons from the widget reference variable and connect each to a collapsed graph. Delete the unused collapsed graphs and reconnect the flow. Sound cues. Step 10. In the impact and slide roll template sound cues, assign the sounds to the random nodes. The velocity of the sounds goes from top to bottom as follows: low velocity to medium velocity and high velocity. Assign each sound to the respective nodes. Do this for all sound areas. Step 11. In the slide roll sound cues, insert the slide sounds to the correct nodes. Slide can have a variation depending on how many trigger boxes are colliding. The box can slide on a vertex, edge, or surface. As with the impact sound cue, 1 is reserved for the vertex collision, 2 for the edge, and 3 and 4 for the surface. To switch sounds on different areas of collision, make a copy of the slide comment section and connect it to the second input of the switch for edge collision. Make another copy and connect it to the third and fourth input of the switch for sliding on the surface. As there is no roll with this object, there is no need to worry about the roll section. Set all of the WAV files to loop. Distinguish between slide and roll. If the object rolls, it is necessary to enable the slide and roll recognition in the central collapsed node. After that, the user must import and assign the rolling sounds to the slide and roll sound cue. The system will automatically switch between the sliding and rolling sounds according to the object's rotation. Single collision. If the user does not want complex collisions using UV light maps or trigger boxes, he can choose single collisions, which will trigger only one sound independently where the hit happened. Adjusting values. When the user starts the game, some instructions appear on the top left corner. To disable the instructions, just press the scroll lock button. The first option, which can be activated by pressing the insert button, tells the user which integer is being sent to the integer switch parameter inside the sound cue. The second option, which can be activated using the home button, reveals the linear and angular velocity of the object. The third option, which can be activated by pressing the page up button, tells the user the velocity of each hit that is above the velocity threshold. The delete button changes the linear, angular, and hit velocity to usable values that range from 0 to 1. The end button changes the UV coordinates to work with the raycast that is sent by pressing the middle button. This feature is useful to discern the areas within the object as described in step 7 of this tutorial. Finally, the page down button has the functionality of drawing a debug point on detected collision. To adjust the values, the user must do the following steps. Step 1. Play the game. Disable the instructions by pressing scroll lock. Activate the hit velocity by pressing page up and switch it to usable values by pressing delete. Play with the object and check the printed values. If the values are too low, the user must decrease the normalized max hit velocity. If the values are too high, then the user must increase the value. The same goes for the linear and angular velocity. While the hit velocity controls the impact sound parameter, the linear velocity controls the sliding sound parameter, and the angular velocity controls the rolling sound parameter. Step 2. Tweak the velocity threshold to a value that seems correct for the impacts. Use the page up feature to guide you. Also, set the velocity threshold zero timer to a lower value than the velocity threshold. This defines the velocity threshold to which the object will still play an impact sound when the timer is below the timer threshold. The timer threshold defines that the object is sliding when the timer is below that threshold, or causing an impact when the timer is above the threshold. When the setup is complete, simply deactivate the prints by clicking this boolean. This video demonstrated how to use this physical collision sound system. Although the system works well for most objects, it needs to be optimized to do certain functions automatically. The user needs to tweak a lot of settings to make this system work properly, but in the end, he will have a very detailed sound collision.